Moving on to the designing of a combination of steel and polyolefin fibers, this lesson presents a research that sought to assess the properties of fiber-reinforced concrete reinforced simultaneously with steel and polyolefin fibers. If we compare the fracture behavior of steel fiber-reinforced concrete, which shows this decreasing branch and best performance at initial crack openings, with that of polyolefin fiber-reinforced concrete with best performance for important deformations, one question turned up. What might happen if the two types of fibers were combined? So let's see. The aim of the campaign that is developed in this video was to produce a hybrid fiber-reinforced concrete with self-compacting properties and meeting structural requirements that may fully exploit the advantages of each fiber material and shape. In order to do so, short hooked-end steel fibers were chosen for the initial strains and 60 mm long polyolefin fibers to improve higher deformations. The individual dosages of fibers were also produced on the same mix design. Therefore, the properties could be compared with results of the mixture with both types of fibers. 4.5 kg meter cube of polyolefin fibers and 26 kg meter cube of steel fibers were chosen in order to maintain the volume fraction in about 0.8% when both types of fibers were mixed. The fresh properties were maintained, and it was visible the higher influence of the steel fibers. Even with the total amount of fibers, self-compacting properties were reached. As expected, few changes appeared in mechanical properties. Just note that steel fibers are able to increase splitting tensile strength and polyolefin fibers not. Concerning fracture curves, the peak load was close for all the formulations, and the hybrid fiber-reinforced concrete reached its maximum even higher than the limit of proportionality for deflections of about 1.5 mm. And moving on to the residual strengths, it is important to say that it remained above 90% of the strength at the limit of proportionality up to significant deformations. And in terms of fracture energy, it could be concluded that some synergy effect took place, increasing the fracture energy about 10% of the algebraic sum of the individual residual strengths. This green area was therefore a synergy effect. So the question appearing was, why does this effect take place? Thus, this had to be explained by means of a fracture surface analysis in which results could be seen that both types of fiber types improved their orientation factor. That is to say, the synergies were explained because each fiber type improved the positioning of the other. So let's summarize briefly what we've covered. A hybrid fiber-reinforced concrete was produced, met the structural requirements, reduced the quantity of steel, and maintained fresh straight properties. Thank you for your attention.